Welcome to this presentation on air masses and fronts, presented by Abdul Muhaimin K. from Kanner University. Let's dive into the fascinating world of atmospheric phenomena. Air masses are large bodies of air with uniform temperature and moisture characteristics over horizontal distances of hundreds of kilometers. They form when air remains stationary over a region for a long period, acquiring the properties of the surface below. Air masses can cover vast areas, adopting the characteristics of their source regions. They are slowly pushed along by high-level winds and share their temperature and humidity with new regions they move into. Air masses are classified using a two-letter system. The first letter indicates whether the air mass originates over land or sea, while the second letter indicates whether it originates in tropical or polar regions. Using this classification, we identify four basic types of air masses: continental polar, continental tropical, maritime polar, and maritime tropical, each with distinct temperature and moisture characteristics. This map shows the global distribution of different air masses and their associated fronts. Notice how they interact and influence weather patterns across the globe. Continental polar air masses originate from the Arctic Basin and other cold regions. They are characterized by dry, cold, and stable conditions, often bringing frigid, clear weather during winter. Maritime polar air masses form over oceans between 40 degrees and 60 degrees latitudes. They are cool, moist, and unstable, often bringing overcast skies and precipitation during winter. Continental tropical air masses originate from tropical and subtropical deserts. They are dry, hot, and stable, maintaining these conditions throughout the year. Maritime tropical air masses form over tropical and subtropical oceans. They are warm, humid, and unstable, bringing mild temperatures and overcast skies in winter, and high humidity and rainfall in summer. Now, let's explore fronts, which are boundaries separating two air masses of different densities. Fronts play a crucial role in weather patterns and atmospheric circulation. A front is a boundary where two air masses of different densities meet. These air masses don't merge easily due to differences in temperature, humidity, and other factors, leading to various weather phenomena. The formation of a front is known as frontogenesis, while its dissipation is called frontolysis. Mid-latitude cyclones often form due to frontogenesis, leading to significant weather changes. Fronts are classified into different types based on their characteristics and the weather they bring. Let's take a closer look at each type. There are four main types of fronts: cold, warm, stationary, and occluded. Each type forms under different conditions and brings specific weather patterns, from thunderstorms to gentle rain. A cold front occurs when a cold air mass pushes a warm air mass upward. This often leads to thunderstorms, heavy rain, or snow, as the denser cold air forces the warm air to rise rapidly. This diagram illustrates the movement of a cold front, showing how the cold air mass advances and forces the warm air to rise, leading to cloud formation and precipitation. A warm front occurs when a warm air mass overrides a cold air mass, gradually replacing it. This process is associated with stratus clouds, overcast skies, and steady precipitation. This diagram shows the structure of a warm front, where warm air slides over the cold air, leading to cloud formation and moderate precipitation. Here is another illustration of a warm front, highlighting the interaction between warm and cold air masses and the resulting weather patterns. Sometimes cold and warm air masses meet, but neither air mass moves over or under the other. This is known as a stationary front. The wind motion on both sides of the front is parallel to the front. Warm or cold front stops moving, so the name stationary front. A stationary front can bring many days of clouds and precipitation. This diagram illustrates the stationary front, where cold and warm air masses meet but do not move. Notice how the wind motion is parallel on both sides of the front. Here, we see a 3D representation of a stationary front. The cool air and warm air meet, causing clouds and precipitation to form along the front. A warm air mass sometimes gets caught between two cooler air masses, or a cold front catches up to a slower-moving warm front. This forms an occluded front. In an occluded front, the warm air mass is cut off from the ground as it is lifted above the two other air masses. This produces cool temperatures and large amounts of precipitation. This diagram shows an occluded front, where the warm air is lifted above the cooler air masses, leading to precipitation and cooler temperatures.